Hello YouTube preppers, this is the Comms Prepper. I know it's been a long time since I made a video, but I've been real busy over the summer and into the fall and now winter out at the retreat location in West Virginia working on a lot of projects. Since our move back from Bolivia, my family has already moved overseas again. My wife got orders to Stuttgart, Germany, and I will be following in a week. So this is my last week here wrapping up my projects, and I thought I'd make a video to show you some of the things I've been doing. Principally installing AREDN, or Amateur Radio Emergency Data Network, around the retreat here. I'm trying to think of how to explain what AREDN is if you're not familiar with it. One answer could be it's a group of really smart guys who've come up with a way to convert wireless internet service provider high-speed data radios into amateur radios, or nodes, amateur nodes, using amateur radio frequencies. It's an operating system that goes on these external radios, converts them to 13 centimeter and I think 5 centimeter band microwave radios. It's a meshed radio network that's based on internet technology, or IP. And out here at the retreat location, I'm running phone, cameras, and retreat automation over AREDN, my off-grid solar power, my rainwater harvesting system, my security cameras. And we're going to try something different here with this video. As you can see, I got the drone up looking down at the retreat location. So first thing I'll do is show you the radios that I have on the roof, or the nodes. Coincidentally, well, I can't get that word out. Trying to get the drone in position here. My internet out here at the retreat is actually provided by a wireless internet service provider that uses the very same radios that you can flash with the AREDN software. So I'm trying to get in here close to the roof without crashing the drone so you can get a real good view of it. And what you'll see there is 3 Ubiquiti NanoStation units up on my roof. Actually, the bottom unit is the node or radio provided by my internet service provider. And the panel pointed up right there is going up to my tower, and the other one is pointed up the hill, and that's a 5 gig node. I'm going to rotate the drone here a little bit, and in the box up there where my off-grid solar power is, I have another node. It happens to be a GLInet that's installed in the box there with a little external antenna. We'll see if I can get in on it. I haven't figured out how to adjust the white balance here yet. But got a little alarm there. Let's get some height so we can get rid of that. So right down there, I'm not sure if you can see it, I'll try zooming in, is a little Wi-Fi antenna. So my off-grid solar power is part of the node as well, or part of the mesh. And then we'll head over to my shed where I have another node, and that's one of my other outbuildings. And here I have my security cameras coming back, and the node sits there in the corner. My security cameras connect to that, and a voice over internet protocol telephone. All my buildings or outbuildings and the cabin have VoIP phones. Now we'll go ahead and go to the top of the property, and you'll see the big tower set up. And all these nodes are actually meshed together, creating a web around the property that is not dependent on the internet. So what I did this summer is I put in a 30-foot tower next to my rainwater collector at the highest point of the property. And I have 2 nodes on this tower, a 5 gig and a 2.4 gig. Let's see if I can get this in the frame better. I thought this would be easier flying and talking, but it's not. So the top panel there you see is what they call a sector antenna, and that's the 2 gig. And below that is a 5 gig antenna. And then I also have a security camera that watches my rainwater collector, and a second camera that can tilt and pan. And that's actually my rainwater collector there. And that node is powered by that solar panel. I actually have 2 panels up there with 2 charge controllers. And I'll take the handheld camera up and show you that. So over the AREDN network from down here in the cabin, I can log into the system and activate and deactivate rainwater collection up there. All right, before we head up to the top of the hill to look at what's at the tower site, I want to show you what I have inside the cabin. I call this my core node, and there's several items inside this 3D printed housing that I made. The circuit card there is a MikroTik HAP access point router with the AREDN firmware loaded, and that's the core node. I have 2 Raspberry Pis. One Raspberry Pi is my email server and my FTP or file transfer protocol server for my security cameras around the retreat. And the Raspberry Pi up top is my Asterisk free PBX telephone system that provides extensions to all the VoIP or voice over internet protocol phones here in the cabin and in the outbuildings. Okay, we finally made it up to the top of the hill where I put the antenna tower. For those of you who follow the channel, things might look a little different up here. We kind of went the scorched earth method and bulldozed all the trees out of the way. This rainwater collector I built 5 or 6 years ago, and I did it on the cheap, and I used poplar. I got a really good deal on the wood and just built it really quickly, but it didn't last as long as I thought it was going to last, and all the beams that were in the ground rotted completely out. And I think this was going to be the last year that this structure would have stayed standing had I not gone behind it and replaced all the support beams in the back. So this was one of the biggest projects I worked on this summer, and putting in this 30-foot tower, which has 2 security cameras on it and 2 AREDN nodes, a 2.4 gig and a 5.8. I also added solar power up here. I have one 160 watt panel going to a PWM charge controller, not ideal. MPPT would be better. And then I had an oddball panel sitting around, so I put this one up on a separate charge controller to keep 2 marine grade batteries charged to power all this equipment up here in a camouflage looking, it was actually OD green, $25 Coleman cooler that I got off of Amazon, and the 2 batteries fit in there perfectly. I still need to dress up these power cables and put some wire loom around them. Again, if you follow the channel, you notice the plumbing is a little bit different now in the rainwater collector. I completely removed the first flush or first wash, and now I'm just going to let the rain come down for 5-10 minutes, and then I'll go ahead and start collecting. Go ahead and come over here, and you can see some of these new posts we put in. 6x6 ground contact pressure treated, and there you can see the old poplar post rotting out. If I get time, I might put one more post back over there. But right now, I think everything's good. It's in good shape. It's very solid again. When I get back from Germany, I'll go ahead and replace the post in the front. I'm not too worried about them right now, because if they rot, they'll just sag down and I can jack it up and put some blocks under it. There's not a whole lot of load here. So let's take a look at the AREDN setup. This has been a major work in progress. I'm going to call this version, I don't know, 90. I had to redo a lot of things in here. I hope you can see okay. I got a busted hacksaw blade as a pointer. So I have a SunForce charge controller that's connected to the panel. It's a 12-volt system. Goes down to the batteries come back up, and a lot of Anderson power pole connectors. But what I'm doing here is up here you'll see this automotive relay. Let me straighten that out a little bit. And underneath that is actually a circuit card I got off of Amazon that has 2 potentiometers, and that's my low voltage disconnect. So if I get a few days that are not very sunny, I can actually run these batteries down, but I don't want to take them down to 9, 8, 7 volts. So I adjusted the potentiometers in here that at 11.3 volts, this relay de-energizes and cuts power to everything in this box. The AREDN equipment uses 24 volts PoE, or power over Ethernet. So what you see here in this module is a 12 to 24 volt buck converter or power supply. I put 12 volts in, I get 24 volts out, and I take that 24 volts out and I put it into what they call a passive PoE injector. It has 2 network connections. You put the power in, and that runs the power up the tower on the Cat 6 cable to power the radio up there. These 2 units here are also PoE injectors. I'm using those for my cameras. This is a 12 volt PoE injector. It's pulling 12 volts power to power the one radio, or sorry, the one camera. The second PoE injector is actually 5 volts to power the ball camera that I can pan and tilt. Coming over here to the door, where it even looks more complicated. The wires got so busy in here, I just put a 12 volt bus terminal block on the door. I bring 12 volts in raw from the batteries, and I run them to this module here, which is a 8 to 30 volts in, constant 12 volt out regulator power supply. If you worked with solar, you know that in peak sunlight, the battery voltage can actually get up to 14 volts, 14 and a half. So there's a lot of fluctuation in the battery voltage during the charging process. Let's see if I throw the switch down where we're at now. So that's 13.4, but that can go as high as 14 at high noon. Well, I don't want to hit all this electronics from 11 to 14 volts every day. So I bring in the fluctuating battery voltage, which is 12 volts nominal. I bring it into this module here, and this provides me a steady, clean 12 volts DC out. And I use that 12 volts to run an Ethernet switch that's behind this charge controller, because all the cameras and all the nodes come down to this Ethernet switch. I also use that clean 12 volts to power this network card, which is a voltmeter. I have 4 contacts to measure voltage and 2 relays that I can control through a web browser. I wanted the voltage reading so I can come in remotely from my laptop, from anywhere in the world or down at the cabin, to see what the status is of the batteries and what the status is of the PoE voltages. So right now I'm monitoring 12 volts nominal from the batteries, that fluctuates. The clean 12 volts coming out of this power supply to make sure I have a nice constant steady 12 volts, and the 24 volts PoE that's running the nodes. Over here is another buck power supply, and this is taking 12 volts again and stepping it down to 5 volts to power that one ball camera that I have. Up here you'll see a DC timer, and I call this my watchdog because I'm getting ready to go to Germany. My neighbor's a ham radio operator, so he's going to kind of be my de facto control operator. I have multiple ways to come in here remotely and shut this down, and if all else fails, I just pick up the phone and call my buddy and tell him to pull the plug. But in case something were to lock up here, like one of the nodes locked up or the camera locks up, I have this switch programmed at midnight and at noon to turn everything off in this box just for 5 minutes. So we get 2 complete resets a day. So at high noon, everything in this box, this switch here, de-energizes this relay here, which cuts power to everything in the box with the exception of the charge controller connected to the batteries. So that brings everything down for 5 minutes, and then it re-energizes everything, and that's my reset. So that's why I call it my watchdog. So if anything goes wrong, I know that at least twice a day, I'm going to get a fresh reboot on this system. I'm also using this system to control this rainwater collector when it collects rainwater and doesn't. This network card has 2 relays that I can control via a website. So I can energize one of these relays, which energizes these 2 relays. And it's those relays, the normally open and normally closed contacts, are actually switching polarity. Open and close, open and close. And what that is doing is controlling this 12 volt actuator arm here, which is connected to this 3D printed housing, which is a door, and then a fitting that I put here on the end of the pipe, and come around this side. So when the rain comes down, if I don't want to collect rainwater, it just hits the top of here and rolls off on the side. If I want to connect rainwater, I'm going to go ahead and simulate coming in over the network by using the manual system. And let me go ahead and reset the tilt here. Up here you'll see 2 rotary timer switches. Now, again, if I'm in Germany, I can call my neighbor and say, hey, we're going to get rain today. He can come over and crank this switch over and open that up. I still have to put the nuts on there. Let's say for 2 hours, and that's timed. So that switch is ticking backwards to 0. And during the time that it's opened or turned on, this armature has actuated, or this armature has activated, and now opened the door and allows me to collect rainwater. This is my replacement for the first wash system. Let it rain for 10 minutes, leave the door closed, and then come in, open up the door, catch the rainwater. I'm waiting for one more part to come from Amazon that goes down there, and that's going to be a mechanical ball valve. So in tandem, when that door up here opens, that you see there, the ball valve is going to close, trapping the water in the filter so we can collect the rainwater. When I deactivate the collection, the door over here will close, and the ball valve down there is going to open, draining the filter out. So I won't have stagnant water sitting in the filter. Something I forgot to do, guys, before I head down and go to the desktop capture software, is I brought my laptop up with a little GL-iNet travel router here. And this is actually flashed with the AREDN firmware as well. So I'm actually into the mesh from this router, or this node, sorry, to the top of the tower. And I have the control software here for the relay. And my neighbor, who's also a ham radio operator, N3LJA, he's going to activate what they call channel 1 here. And I'm going to put the mouse right over that with the pointer, and he's going to click that for us, and you'll see the rainwater collection start. All right, I had to show my buddy how to use my mouse. He's going to activate channel 1. And he's done this over the network, over the node, to open up that actuator arm to expose the opening to my system. Again, when I get my part tomorrow, at the exact same time, a motorized ball valve at the bottom of the filter would have closed. And that's all being controlled by this card here, and I'll put a link down below. It's a NC240 net controller. I had to get this from Thailand. I really like the voltage meters on it. There's other network addressable relay cards, but I wanted the voltmeter as well. All right. So that's the show and tell there. We're going to get my buddy to go ahead and deactivate that relay. And there it is. It's closing up. And again, that ball valve, when it comes, would now be opening, and all the water in that filter housing would drain out. So nothing would be trapped in the filter. So if it freezes or it sits there for a long time and gets stagnant, I don't have to worry about it because it's going to drain right out of the bottom. And again, we'll show you one more shot of the box before we get into the warmth. All right, it's a little later in the day today, back at the cabin, and now we're going to wrap this video up with the desktop capture software. Right now I'm on the web page for the Amateur Radio Emergency Data Network, or AREDN. The website is AREDNmesh.org. I'll put a link down below. And to give you an idea of how this system is growing, I'll go here and look at the map for you, and you can see how more and more amateur radio operators are getting into AREDN and mesh radio. So we'll kind of zoom in here. Each one of these dots is color coded for the applicable ham radio band or the hardware that's modified. We'll zoom in to West Virginia and you'll see my station here. We'll zoom out. We'll go ahead and close that. And if you're looking to get into AREDN, you want to come here to Software, Supported Platform Matrix. And this is a list of the commercial products that you can buy that have firmware written for them supported by AREDN. So they're color coded here. If you click on these links, they take you directly to Amazon. This isn't done so AREDN makes money. It's done because each one of these links makes sure that you check the right radio with the proper chipset in it to accept the firmware. You have Microtech, Ubiquiti, TP-Link, and GL-iNet. And then the color code is down here of where that firmware status is at. Another good link to know once you get into AREDN is the nightly builds. This is where the firmware updates are found. I'll go here to Ubiquiti firmware, for example, and I can find all my Ubiquiti units, the local MXW. You can see I've already downloaded these because I just recently did a firmware update. So we'll go ahead and click on my core node. That's the thing that's on the wall in the back with the 2 Raspberry Pis and connects to the roof. So I'm going to click here to mesh status, and this is basically all the other mesh units that my core node sees. So it has a link to the 2 gig radio on the roof, the 5 gig radio, and I have a tunnel, which is something that's done over the internet. We're not going to get into that with this video. If I click on the 2G radio, now I'm looking at the node that's on the roof and hit mesh status. Now I get a list of everything that it can see. So what you see here are RF links. So the unit on the roof sees the 2G Romney that's on the tower. Of course, the 5G cabin, which is next to it, but it says DTD. That means it's a cable connection. The core node, DTD, that's a cable connection. The off-grid solar power, that's an RF connection. Then you have link quality and neighbor link quality. And then my old shed with the link quality and the amount of data getting passed. So first thing we'll do is, let's say I'm curious and I want to know what the voltage is of the batteries up at the tower. I can go here and click on this link. And now I'm accessing that net control card that I showed you in the box earlier, and it's telling me that channel 1 and channel 2 are off, which means those relays are off that open and close the gate for my rainwater collection. My PoE output voltage 24.19 because I have 24 volt PoE injectors, and then the battery voltage is 12.35. Then we'll go and look at the camera up there. So I have a PT or pan and tilt camera. We'll pull that up. I'll put my password in. And now I can see what's going on up the rainwater collector. I can see that the gate is closed, so no water can get down into the system. And I see the lights over here for my water level. And of course the road, and if I wanted to move this I could, and I could check things out up there, make sure nobody's tampering with my system. And this is also set for motion detection, so anytime this thing sees motion, it'll actually save 3 pics down through the system to the Raspberry Pi, the FTP server. We'll go ahead and close that out. I have another fixed camera up there. I'll go ahead and open that up for you. I want to reposition that to face the other way. Right now it's looking at the same angle as the other camera, but of course this is a fixed camera, I can't move it. We'll come down to my off-grid solar power. So maybe I want to know what the status is of my charge controller and my off-grid solar power system that I use to watch TV and run the computer here at the cabin. So I click on charge controller. This is an RF connection. I'm going out to my charge controller now. And of course it's pulling all this data over the mesh. So my current battery voltage is 12.73. Array voltage 1 volt, so must be a little moonlight out. Battery temperature is 4 degrees Celsius. Heat sink is 5. I can come up here and actually look at my charge rate and look at my history so I can see how much sun I got today. And I'm doing all this from the lazy boy in the cabin. Wait for this data to populate. Charge controller is always a little bit slow to populate this option. So okay, today I had 180 minutes of absorption, 120 minutes of float, no equalize, and my event today is I went to float status. So this is a really good charge today. As you can see, these previous days weren't very good because we had a little bit of snow and a lot of cloud cover. All right, so we've used AREDN to look at my off-grid solar power, check the voltages up at the tower itself, look at security cameras. We also have a cat. We adopted a cat kind of over the summer, and the kids named it Cabin Cat. So I built a little house or a little box for it out by the shed. Of course, we got it all shots and all that good stuff. And we put a little food and water out there for the cat. So maybe the cat's in the box right now. The cat is not in the box. All right. Or maybe the cat's on top of it. There's the cat. All right. So the cat's snoozing, sleeping on top of the little teepee thing that we got for it. So it's got some food, some water, and now it's taking a nap. So let's see if we can't wake the cat up. Get the cat going. I'll turn the microphone on. Meow. Psst, psst. Meow. All right, the cat's moving now. All right. So that's enough with the cat. So these are the things that I'm doing with AREDN. And of course, I also have IP phones in the outbuildings. I'll pull up the PBX link. You can't see it because I'm not getting the whole desktop. But this is free PBX. So right now I have 2 users online and 9 users offline. So my neighbor up top of the hill has his system shut off. I have a couple of trunks that people aren't accessing it. But as I want to add extensions, I can come over here and go to extensions and add extensions here. These are all the stations I've made extensions for. And people can actually hook up a phone, log into the mesh, and access my PBX. So we'll go back to the AREDN webpage. Maybe. There we go. These are the actual frequencies for 2.4 gig. This is the ham bands here. So there's 2 channels below traditional Wi-Fi. This is Wi-Fi channel 1. But with your ham radio license, you actually get channels below that. So you don't have to have a bunch of interference. There's also 5 meg frequencies. Here's a nice tower view. So that's my video on the Amateur Radio Emergency Data Network. I'm sorry if it's convoluted or confusing, but I got to get ready to get to Germany, and I just kind of wanted to put it all together and show you the potential for emergency preparedness and preppers and how you can leverage AREDN to support your emergency communications plan. And as always, thank you for watching my videos and subscribing to my channel. This has been the Comms Prepper with a video about the Amateur Radio Emergency Data Network. Thanks for watching, everybody.